Episode 2, The Clockwork Mind, Mechanism, Measurement, and Descartes. Welcome back to Dr. Jackal's History and Systems of Psychology podcast, where we trace the strange, brilliant, and occasionally messy road that made psychology into a science. Today's warning label: history contains names, dates, and several very confident men with measuring devices. But we are not here just to memorize a timeline. We are here to track something more interesting: how people changed their minds about what counted as evidence, what counted as science, and eventually, what counted as the mind itself. And today's episode is a big one, because we are entering the age of the machine. Not literally. No one is turning into a toaster, but intellectually, culturally, scientifically, absolutely. This is the moment when people started looking at the universe and eventually the human body as if it worked like a machine, orderly, predictable, measurable, and governed by laws. And once people started thinking that way, it changed everything. Part 1. The Mechanistic Worldview. Let's start with the word mechanism. Mechanism is the idea that the universe operates like one enormous machine. Every event has a cause. Every movement follows a rule. Every effect can, at least in theory, be traced back to something that produced it. This idea grew out of physics, especially through the work of figures like Galileo Galilei and Isaac Newton. They helped promote the idea that the universe was made of matter in motion. Objects moved according to laws. The planets followed orderly paths. Falling objects behaved in predictable ways. Nature was not random chaos, it was structured. And that idea was thrilling. Because if the universe followed laws, then human beings could study those laws. If scientists could observe carefully enough, measure precisely enough, and experiment systematically enough, they could begin to predict how the world worked. That is a huge shift. Science became increasingly tied to observation, experimentation, and measurement. And measurement became almost sacred. Thermometers, barometers, pendulum clocks, micrometers, slide rules. Measuring instruments became symbols of the new scientific age. The attitude was something like this: if something is real, we should be able to observe it. If we can observe it, we should be able to measure it. And if we can measure it, we can understand it scientifically. That way of thinking is going to matter deeply for psychology later, because psychology will eventually have to answer a very difficult question: can the mind be measured? Part 2. The Clockwork World. Now, if there was one machine that captured the spirit of this age, it was the mechanical clock. The clock was not just a useful object. It became a metaphor for the entire universe. Historian Daniel Boorstin famously called the clock the mother of machines, and that phrase fits beautifully. The clock represented order, precision, regularity, predictability. Before clocks became common, people experienced time more loosely. Daily life was shaped by sunrise, sunset, seasons, bells, meals, labor, and religious rhythms. But clocks changed how people lived. Suddenly, time could be divided into exact units: hours, minutes, seconds. Daily life could be scheduled, coordinated, and disciplined. Punctuality became important. Productivity could be measured. Human activity itself began to be organized around time. And this mechanical view of time shaped how people thought about the world. If a clock could keep perfect order through gears, springs, and weights, maybe the universe worked the same way. Maybe the planets moved like parts of a cosmic clock. Maybe the body worked like a machine, and eventually, maybe even human behavior could be understood mechanically. That is where things start moving towards psychology. Part 3. God as Clockmaker. This clock metaphor also influenced religion and philosophy. Many thinkers adopted what is sometimes called a deist view of God. In this view, God was imagined as a kind of cosmic clockmaker. The idea was that God created the universe, designed its laws, set everything into motion, and then allowed it to run according to those laws. So instead of imagining the universe as something requiring constant supernatural intervention, many thinkers began imagining it as a divinely designed machine. René Descartes was deeply influenced by this mechanical worldview. He believed that the universe had order and harmony, and that this order could be understood mathematically and scientifically. This mattered because the same logic used to understand planets, clocks, and machines began to be applied to human beings. And that is a massive turning point, because once human beings are compared to machines, scientists begin asking, can the body be studied like a machine? Can behavior be predicted? Can mental life be explained by physical processes? Where does the mind fit into all of this? Those questions are central to the birth of modern psychology. Part 4. Determinism and Reductionism. Two major ideas come out of this mechanistic worldview: determinism and reductionism. Let's take them one at a time. Determinism is the belief that every event is caused by prior events. In other words, things do not simply happen for no reason. Every action, every movement, every physical event has a cause. If the universe is like a clock, then each movement of the gears is caused by what came before it. Nothing is floating freely outside the system. Applied to human beings, determinism raises some uncomfortable but important questions. Are our actions caused by prior events? Are our choices influenced by biology, environment, experience, and habit? How much freedom do we actually have? These questions are still alive in psychology today. Behaviorism, neuroscience, cognitive psychology, and even modern debates about free will all carry traces of this deterministic tradition. The second idea is reductionism. Reductionism is the belief that complex things can be understood by breaking them down into simpler parts. If you want to understand how a clock works, you open it up and examine the gears, springs, levers, and weights. If you want to understand the physical universe, you break it down into matter, particles, molecules, and atoms. Eventually, scientists will try something similar with human beings. If we want to understand behavior, maybe we should break it down into reflexes, sensations, associations, neural processes, or stimulus response patterns. Reductionism becomes one of the major habits of modern science. It can be incredibly useful, but it can also be limiting, especially when we are studying something as complex as human thought, emotion, consciousness, and identity. So remember, mechanism gives psychology a scientific foundation, but it also creates tension. Psychology gains measurement, method, and precision, but it also risks treating human beings as if they are nothing more than machines. Part 5. Automata and the Dream of Mechanical Humans. Now we need to talk about one of the strangest and most delightful parts of this story: automata. Automata were mechanical devices designed to imitate living beings. Some looked like animals, some looked like humans, some could move, play music, write, or perform gestures, and people were fascinated by them. To modern eyes, automata might seem like elaborate clockwork toys, but to people at the time, they were astonishing. Imagine seeing a mechanical figure that appeared to breathe, move its fingers, play an instrument, or imitate human action. In a world already captivated by clocks, automata seemed to suggest that life itself might be mechanically reproduced. One famous automaton was the defecating duck, designed by Jacques de Vaucanson. Yes, that is exactly what it sounds like. It was a mechanical duck that appeared to eat, digest, and excrete. It was strange, impressive, and deeply memorable, which is probably why students never forget it once they hear about it. Vaucanson also created mechanical musicians, including a flute player. These machines used complex internal systems of wires, gears, and mechanical parts to imitate lifelike action. Another famous automaton, sometimes called the lady musician, appeared to play melodies on a keyboard. Her fingers moved over the keys, her eyes moved, and her body gave the impression of breathing with the music. These machines strengthened the idea that living action could be explained mechanically. If a machine could imitate human movement, maybe human movement was also mechanical. If a machine could appear lifelike, maybe life itself was not so mysterious after all. This is where the cultural imagination starts to shift. Human beings were increasingly described as complex machines. And once that idea takes hold, psychology becomes possible in a new way. Because if human action follows laws, then behavior can be studied scientifically. Part 6. Machines in the Cultural Imagination. The machine metaphor did not stay inside laboratories and philosophy books. It spread into culture. Literature, children's stories, and popular imagination began to reflect the fascination and anxiety surrounding mechanical life. Mary Shelley's Frankenstein is one of the most famous examples. Frankenstein is not technically a robot or a clockwork machine, but the novel captures the fear that science might assemble life, manipulate nature, and create something human-like but deeply unsettling. Later stories like The Wizard of Oz include mechanical or machine-like figures such as the Tin Woodman. Again, we see this fascination with human beings, machines, bodies, and souls. These stories matter because they show us that scientific ideas do not stay in science. They shape the broader culture. That is what we mean by zeitgeist, the spirit of the time. The mechanistic zeitgeist made it easier for people to imagine bodies as machines, behavior as predictable, and the mind as something that might eventually be studied scientifically. And that brings us to one of the most important figures in the history of psychology, René Descartes. Part 7, Descartes enters the story. René Descartes was a French philosopher, mathematician, and scientist. He is one of the major transitional figures between older theological traditions and modern scientific thinking. Descartes wanted certainty. He wanted knowledge that could not be easily doubted. He believed that mathematics offered the clearest model for certain knowledge, and he wanted to apply that kind of clarity to philosophy and science. His basic method was radical doubt. He decided to doubt everything he could possibly doubt until he found something absolutely certain. That search led him to his famous conclusion: I think, therefore I am. The point was not simply that thinking is interesting. The point was that the act of doubting proved the existence of the thinker. Even if Descartes doubted everything else, his senses, the external world, his body, he could not doubt that he was thinking. For psychology, this matters because Descartes placed the thinking mind at the center of philosophical inquiry, but he also gave the body to science, and that combination creates one of the most important problems in psychology, the mind-body problem. Part 8, the mind-body problem. The mind-body problem asks, what is the relationship between the mind and the body? Are they separate? Are they the same? Does the mind control the body? Does the body influence the mind? How does something mental, like a thought or intention, produce something physical, like movement? And how does something physical, like light hitting the eye, become a conscious experience? Before Descartes, many thinkers emphasized the power of the soul or mind over the body. The mind was often treated as higher, spiritual, and separate from physical matter. Descartes agreed that mind and body were different substances. The body for Descartes was physical. It had extension, it occupied space, it followed mechanical laws. The mind, however, was non-physical. It did not occupy space in the same way. It was the source of thought, will, and consciousness. This position is called dualism, the belief that mind and body are distinct. But Descartes made an important move. He argued that the mind and body interact with each other. The mind can influence the body, but the body can also influence the mind. That mutual interaction opened the door for scientists to study the body more seriously as part of psychological life. If bodily processes affect mental experience, then physiology matters. If sensory input affects thought, then perception matters. If bodily mechanisms can produce behavior without conscious intention, then psychology needs to study more than conscious reflection. This is why Descartes is so important. He did not create psychology as a modern scientific discipline, but he helped make it thinkable. Part 9. The body as machine. Descartes believed the body operated according to mechanical principles. To understand this, think back to the automata. Descartes had seen mechanical figures that moved when water pressure, gears, or hidden mechanisms were activated. These machines appeared to act purposefully, even though they had no mind. Descartes used this idea to explain bodily movement. He argued that many bodily actions happen automatically, without conscious thought. For example, if you touch something hot and pull your hand away, you do not calmly sit there and reason through the decision. You react. That reaction feels immediate and automatic. Descartes described this kind of movement as undulatio reflexa, which later becomes part of what we now call reflex action theory. This is a major step toward later psychology. A reflex involves an external stimulus producing an involuntary response. In modern terms, we might describe this as part of a stimulus-response pattern. Stimulus, heat, response, pulling your hand away. That may sound simple, but it becomes foundational. Later, behaviorists will build entire theories around stimulus-response relationships. Pavlov's classical conditioning, for example, comes much later, but Descartes had already anticipated part of the logic. External events can trigger bodily responses without conscious choice. This is one of the places where we can see the long historical road to modern psychology. Descartes is not a behaviorist. He is not a cognitive psychologist, but his thinking helps create the conditions for both. Part 10. The mind still matters now. We should be careful. Descartes did not say that everything about human beings was mechanical. He believed the body was machine-like, but he believed the mind was different. For Descartes, the mind was responsible for thinking, reasoning, willing, and conscious awareness. The mind interpreted sensory information. It made judgments. It guided voluntary action. This distinction allowed scientists to study bodily processes objectively while still preserving a special role for the mind. And that is part of Descartes' complicated legacy. On one hand, he encouraged a mechanistic view of the body. This helped physiology and later psychology become more scientific. On the other hand, by separating mind and body so sharply, he created a problem that psychology has been wrestling with ever since. Where exactly is the mind? How does it relate to the brain? Can mental processes be explained physically? Is consciousness something separate, or is it produced by the nervous system? Modern cognitive psychology, neuroscience, and philosophy of mind are still working through versions of these questions. Part 11. The pineal gland. Descartes also believed that the mind and body had to interact at a specific point in the body. He chose the pineal gland, a small structure located near the center of the brain. Why the pineal gland? Descartes thought the mind was unified, meaning it was one single, indivisible thing. So he looked for a structure in the brain that also seemed singular rather than duplicated across both hemispheres. The pineal gland appeared to fit. Today, we do not believe the pineal gland is the seat of the soul or the central meeting point between mind and body. We associate it more with melatonin and biological rhythms. But historically, Descartes' focus on the brain mattered. Even though his specific answer was wrong, the direction was important. He located the mind-body interaction in the brain, helping shift attention toward the nervous system as central to psychological functioning. And that matters enormously for the later development of psychology. Part 12. Innate and derived ideas. Descartes also distinguished between derived ideas and innate ideas. Derived ideas come from experience. For example, if you see a tree, hear music, or touch a warm cup, those ideas arise from contact with the external world. They are derived from sensory experience. Innate ideas, however, are ideas Descartes believed were present within the mind itself, rather than learned directly from experience. Examples include ideas like God, the self, perfection, and infinity. This distinction becomes part of a much larger debate in psychology and philosophy. How much of the mind comes from experience, and how much is built in? That question will show up again and again. It appears in debates between rationalism and empiricism. It appears in arguments about perception, learning, language, and development. It even appears in modern psychology when we ask what humans are born prepared to know or learn. So again, Descartes is not just one historical figure to memorize. He is a hinge point. He connects older philosophical questions to newer scientific methods. Part 13. Why this matters for psychology. So let's pull this together. The mechanistic worldview gave psychology several tools and assumptions that would become incredibly important. First, it gave psychology the belief that natural phenomena can be studied through observation and measurement. Second, it encouraged scientists to search for lawful patterns in behavior and bodily processes. Third, it promoted reductionism, or the idea that complex systems can be understood by breaking them into parts. Fourth, it encouraged the study of reflexes, physiology, and automatic behavior. And fifth, it sharpened the mind-body problem, which is still one of the deepest issues in psychology. This is why history matters. Psychology did not simply appear one day as a finished science. It emerged slowly as people borrowed metaphors, methods, and assumptions from the sciences around them. Physics gave psychology the dream of laws. Clocks gave psychology a metaphor for order. Automata gave psychology a model for automatic behavior. Descartes gave psychology a mind-body problem it still has not fully escaped. And from here, the story keeps moving. Because once people begin thinking of the body as a machine and the mind as something that might be studied systematically, the next big question becomes, where do ideas come from? Are they built into the mind, or are they written there by experience? That question will lead us toward empiricism, associationism, and eventually the foundations of experimental psychology. Wrap up. The big takeaway from today's episode is this. Psychology became possible because people changed the way they thought about nature, bodies, machines, and knowledge. The names matter, yes. Newton matters. Galileo matters. Descartes matters. But the deeper pattern matters even more. Each figure is responding to the problems left behind by the last one. If the universe is lawful, maybe the body is lawful. If the body is lawful, maybe behavior is lawful. If behavior is lawful, maybe psychology can become a science. That is the turn we are watching happen. The road to psychology is not clean or simple. It is full of strange machines, bold metaphors, philosophical puzzles, and occasional mechanical ducks. But that is what makes it fun. That's it for today. Keep your curiosity sharp, and I'll see you in the next episode. This is Dr. Jackal, signing off. This episode uses AI-generated narration to bring Dr. Jackal's voice and character to life. However, the ideas, framing, and wording are my own, Dr. Alyssa R. Jones. The content has been synthesized, paraphrased, and adapted from history of psychology textbooks, scholarly work, lectures, professors, and other educational resources that have shaped my understanding of psychology, science, philosophy, and the mind. AI is used as a creative teaching tool, but the educational interpretation,